Bandwidth shaping, also known as traffic shaping, is a network management technique used on switches. Bandwidth shaping's main job is to keep the network running smoothly. It does this by stopping any one user or app from using up all the internet speed. Otherwise, it could slow things down and make it harder for everyone else to use the network. In this episode of Cisco Tech Talk, I'll show you how to configure and monitor bandwidth shaping on Cisco Catalyst 1200 and 1300 series switches. Next. To show how bandwidth shaping works, I have created a simple setup with two PCs connected to two ports on the Catalyst switch. Both PCs have jperf installed. jperf is a user-friendly tool built on Java that enhances iperf, a network testing tool. It visually presents the performance of TCP and UDP traffic on a network, aiding in measuring network throughput. In bandwidth shaping, a jperf server is the recipient in a network performance test. jperf gauges the network's performance between them. It verifies how effective your shaping rules are. It measures the actual throughput of varying traffic types under different conditions, helping optimize your settings for the best network performance. In this example, the first PC works as a client, sending traffic to port G3. The second PC works as a server, accepting traffic on port G5. The jperf window shows both the client and the server. I'm using UDP packets at the maximum speed and a buffer size of 3 megabytes. Run the client and the server. The jperf client is sending and the jperf server is receiving traffic at the maximum speed. Once you have checked the client and server, log into the switch and select Advanced Mode. To check the port utilization, navigate to Status and Statistics and select Port Utilization. Here you can see port 3 is receiving and port 5 is transmitting traffic at nearly 100%. Navigate to Quality of Service, select General, and then click on Bandwidth. To limit the incoming traffic on port 3 from the jperf client, I'll select port GE3 and click Edit. In the Edit Bandwidth window, enable the ingress rate limit to restrict the traffic entering the port. I'll limit it to 50%. As the value is in kilobits per second, I'm going to enter 500,000 kilobits. Ingress Committed Burst Size, CBS, limits the total amount of bytes allowed above the ingress rate limit for burst traffic. For this example, the CBS will be at the default value. If large files are transmitted, you can change the size accordingly. Once you have configured the bandwidth settings, click Apply. I have port 3 enabled. Navigate to Status and Statistics. Select Port Utilization and refresh the page. As you can see, the ingress traffic on port G3 is the same, but the outgoing traffic on port G5 to the server is limited to 50% by the switch. If you check the jperf client and server, you can see the client is sending close to the maximum speed. However, the server is receiving at 50% of the packets. You can get this same result by limiting the egress traffic. This is the traffic coming out of the port. Navigate to Quality of Service, General, and then Bandwidth. I'll disable the ingress limit of port GE3 and select port GE5. I'll edit the settings to limit the egress traffic coming from it. Here, enable the egress shaping rate and enter the Committed Information Rate, CIR. I'll enter a value of 500,000 kilobits per second and click Apply. The traffic coming out of the port has been limited, and you can see that the same outcome is achieved. Generally, even though the egress traffic is limited to 50%, there is excessive traffic that is processed by the switch that will be filtered at the outcome. There you have it, bandwidth shaping, a flexible, powerful tool for maintaining optimal network performance and reliability. Thanks for watching. I'll see you next time.